What is up, amigos? Today we're talking about something called ventilation drag, and it's kind of like a phantom drag, and we'll see why in a second. It's not very well known at all. So we're going through what it is and how to measure it, because the reason why it's not really known quite extensively is because it is very hard to measure, and we have to change our setup to measure it. So let's talk about a regular car to begin with. Let's say we have a regular car here, and nothing out of the ordinary. We have some wheels, and we know that there is a drag on this car, and this drag comes from, you have friction drags, pressure drag, vortex drag, and induced drag, the cooling flow drag, a bunch of other things. So if we were to connect this car to a load cell, which is what we do in real life, we put it into a wind tunnel, and we have the regular floor around here, and then we have struts connecting the car all the way down to a load cell underneath. We also have now things called wheel drive units, which are these belts on two rollers, or however many rollers you want, and this spins the wheels. This belt rotates around, which then spins the wheels around. This way, and then the wheels spin that way. And these wheel drive units are also connected to the load balance as well, the load cell. So we put the car into the wind tunnel, we run the air, we measure the drag, lift, side force, moments. With this load cell, have we got all the drag of this car? Well, the answer is actually no, we don't. And for something called the ventilation drag. So let's talk about what this is. Let's say we have a regular wheel here, and we're just blowing this up. So let's say we get this wheel, and let's expand it here, and we have a bunch of spokes. And we also have tread going along here, and I've just made the tread a lot bigger than what it should be, but just so we can see. So we know that this wheel is rotating this way for the car to go forward. And if you think about these rims, these spokes, as they rotate around, they're chopping through the air. And let's take this spoke, for example. Now, as this spoke comes down, it's going to chop through the air, and that means that there is some resistance that this air is placing on this spoke, pushing it backwards, trying to resist it from rotating around. And we have the same thing going for all of these spokes as well as the tread. The tread goes around, and it's hitting air that's coming in, and it's resisting the wheel spinning around. Now, that doesn't mean that there's no drag here, because the engine still has to produce enough torque to overcome this resistive force trying to resist this wheel rotating around, this resistive torque. That's to come from somewhere, it's the engine. Now, if we were to put the car into a wind tunnel like this regular setup, which is what pretty much all automotive manufacturers use, will we measure this ventilation drag with this setup? Well, the answer is actually no. And the reason why is because the forces that are involved in this process is actually coupled with the wheel drive unit. So the more force the greater the ventilation drag, the more force that this air is placing on these spokes, resisting the wheel from moving, as well as the tread, the more force this wheel drive unit has to push along to rotate this wheel. Now, that's where we reach a problem. So the amount of force required to rotate this belt, so the torque, is an internal force. It's all within the wheel drive unit itself. It's not actually coming through into the strut here, into the load cell. So that means that any force required to rotate this wheel, this ventilation drag, is actually an internal force of this wheel drive unit, and we cannot measure it with this setup. As such, we don't usually measure it. So when we quote the drag of a regular car, let's say it's 0.26, which is a pretty good drag coefficient for a car, that's not including the ventilation drag. So is it really that important though? Well, the answer is yes. So the ventilation drag, if you were to measure it, and we'll get into a second how to measure that, if you were to measure it and calculate what the ventilation drag is and look at the drag coefficient, let's say a regular car has a drag coefficient of 0.26. Well, the ventilation drag can range anywhere, let's say, range between 0.01, let's say that's the lower limit, to 0.06. So 10 counts to 60 counts. That's a lot. So if it's only 10 counts, okay, that's not that much, it's a few percent. But 60 counts compared to 260 counts, that means ventilation drag is an additional 23% more drag on this car. So that means that we have 23% more drag that we're not taking into account with this way of measuring the drag of the car, because this is an internal force. So the car is actually more like 0.32, the drag coefficient, when we go on the real life, like a road driving along. In the wind tunnel, we're not measuring this additional 23% or whatever it is. So that brings us to how do we measure the ventilation drag? Well, there are two main ways, and the most common way is we actually put force, like load cells and force sensors in these wheel drive units to actually measure how much force is required to rotate these belts around. That is directly coupled to the wheel, the ventilation drag, as well as the rolling resistance. We can then get the rolling resistance out of that by running the car at a very low velocity and assuming that the rolling resistance is constant along the velocity that we are driving along. That is an assumption, yes, but it is a pretty decent assumption. We might get a few percent error there. But compared to the 20% that the ventilation drag increases the car's drag by, that few percent in the ventilation drag is not that much of a problem, at least these days, because no one's actually measuring this anyway, so measuring it to begin with is actually pretty good. So we put force cells into these wheel drive units, and that's pretty good. But we need to be careful with this, because if we do change the wheel drive units, there's no guarantee that when we put it back, it's actually going to be the exact same way. And this entire setup is a multi-million-dollar setup, so we want to make sure that we get it right. And if we do break it somehow, well, that means that you can't actually do wind tunnel measurements until you get this fixed, and you only have one of these. Alternatively, where the wheel meets the axle, we can decouple that and put a torque meter in there to see how much torque is required to rotate the wheels around. That's a good way as well, and it's also a cheaper way effectively and a less risky way, because if you screw it up and the car gets screwed up somehow, okay, the car might be $50,000, $100,000, but it's not a multi-million-dollar system, and you have lots of different cars, so you can get another car in and keep going with your tests. So that's not as big a deal. So that is what ventilation drag is and how important it is in the overall drag coefficient of a car. So that's it in this video. If you'd like to, make sure to like it, click the subscribe button, and I'll see you next video. Peace, amigos.